So now, using this concept, we will look at few more interesting experiments. So let's look at this experiment with balloons. So what we do here, take two balloons. Again, these are all simple experiments which can be very easily tried at your home. So take two balloons, blow them up, and then attach them to a string as is shown on the screen. So you just fix these balloons and leave a considerable distance between the two balloons. Now at the same time, they should not be kept very far apart. So like a considerable distance between the two balloons, tie them to a string. Now what do? You blow hard in the space between the balloons. So when you blow hard, so what happens when we blow? So when we blow, the region in front of our mouth, this particular region, there will be movement of air. So there will be, that region will have higher wind speed because the air will be moving faster because of our blowing. Now what happens due to this when we blow? Now an interesting thing happens. We see that the two balloons tend to come closer to each other. So as we blow, the two balloons start coming near each other. So the question is, what causes these two balloons to attract each other? So why are they experiencing an attractive force between themselves? That's because what happens is when we blow hard, basically the region between these two balloons, in this region, somewhere here, the wind speed is more. Now, I have told you something before. When the region where wind speed is more, it will always be accompanied with low air pressure. Therefore, the air pressure in this region is less because wind speed is more. We learned about it, right? That when wind speed is more, the air particles are moving really fast. So they do not have enough time to exert pressure on objects. Therefore, the air pressure is low. So basically in this region, so if we name these regions as region 1, region 2 and region 3. So what do we see? That region 2 comparatively have lower air pressure. So the air pressure in region 2 is less, but the air pressure in region 1 is high. So I'm just talking about comparative values. So in region 2, the air pressure is less when compared to region 1. Similarly, when compared to region 3, also region 2 has less air pressure. So basically here air pressure is more, here air pressure is more, but in this region the air pressure is less. So what will happen? So air tends to flow from a region of higher pressure towards lower pressure. So air will flow in this direction. Similarly, in this case, air will flow in this direction from region of higher pressure towards region of air pressure. Now, as air blows, as wind blows, what happens? It exerts a pressure on the balloon which makes the balloon also move in the direction of the wind. And as a result, they both tend to come near each other. So that is why this attraction happens between the balloon. So this happens only when we blow in between the space between the two balloons. Because when we blow hard, only then the wind speed in region 2 increases, because of which the air pressure is reduced. So that's how you see these are simple experiments, but a lot of time we do not know why this happens. And that is very much important to know if you really want to understand the science around us. Let's look at yet another example, which is a very popular experiment, you can say. So here we will make use of paper balls and a bottle. So all you need is one bottle. Take a small ball of paper. So what is a paper ball? Basically, you take a small sheet of paper, just crumble it to form a tiny ball. Now, you have to ensure that the size of the ball should be such that it is smaller than the mouth of the bottle. So that, it is possible to put it inside the bottle. So that is how the size of the paper ball should be. Now you try this out. So place the bottle like this, hold it in your hand like this, and put that small paper ball just at the mouth of the bottle. And then you blow hard. Now when you blow hard, what do you expect? Now since we are blowing hard, we are trying to push this ball into the bottle. So that is our aim, because we think when we blow hard, we are exerting some pressure on this ball and therefore it should move in. But actually what happens, do you know that? So when you actually blow on the ball to force it into the bottle, the result is that instead of going inside the ball tends to come out of the bottle. So the ball all the more come towards the outer side. That's quite surprising again, because we are thinking that when we are blowing hard, we are exerting a pressure to the ball so that it can move in. But instead of moving in, it is moving out. So let's try to understand what happens here. Now, when we blow into the mouth of the bottle, again, the air which is present near the mouth of this bottle, the speed of the air increases because we are blowing hard, right? So the wind speed at the mouth of the bottle would be more. So basically, in this region, the wind speed would be more. Now, when the wind speed is more, so this will be accompanied by lower pressure. Therefore, the air pressure would be less. So, reduced air pressure. Where is the air pressure reduced? At the mouth of the bottle. Correct? But air pressure inside the bottle, how is it? It is more. So because here we are talking about comparative value. So when we blow hard at that point of time, since the wind speed in this region increased, therefore the air pressure reduced. But inside the bottle, the air pressure is comparatively more. Correct? Now, what have we learned? We have learned that air moves from region of higher pressure towards region of lower pressure. So basically, the moving air or the wind will actually move in this direction. Now, wind exerts pressure, so this wind will exert a pressure on this ball, and therefore the ball tends to come out of the bottle. So that's the logic. So even though we are blowing hard, we are thinking that we are directly giving some force to the ball. But actually when we are blowing hard, we are increasing the wind speed in that region. And since the wind speed is increasing, so the air pressure is reducing. And due to the difference in air pressure, the wind starts flowing in the opposite direction, which makes the ball move out. So all these experiments tell you that the concept of air pressure exists, because you see, if you say that no, I would not agree that something like air pressure exists, in that case how would you be able to explain all these phenomena which happens? Because this is not something imaginary, this actually happens. You can try this experiment yourself. So how would you justify this experiment if you do not believe in the concept of air pressure? So we will again look at a beautiful experiment, and here we will make use of a strip of paper. So here what we do is, instead of the bottle, now we take a strip of paper, as you can see here, a thin rectangular tiny strip of paper. So, and you hold it near your mouth, but we are not doing anything but just holding it near our mouth. So just look at the way the strip of paper is. So it will be like kind of hanging, because you know it is not a very thick sheet of paper, it is just a normal thin strip of paper. So it tends to be like this, it doesn't remain straight and all. Now you just try to blow it. Now when you try to blow hard, in this case, what happens? Now before the strip was hanging like this, but now it tends to move in the upward direction. You see, somewhat it has moved in the upward direction. Earlier it was like this, now it is like this. So this happened because we are blowing it from here. Again, that is also surprising. Now we are not applying any pressure in this direction. We are basically blowing it hard in this direction, which should actually make it go all the more down. But instead of that, it is moving, it is coming up. So why is that? Again here, when we blow hard, what happens? The wind speed in this region increases. So let's call this region as region 1 and this region as region 2. So the region above the strip of paper is region 1 and the region below the strip of paper is region 2. Now when we blow hard, we are actually blowing in region 1. So what happens in region 1? So here the wind speed increases. Now when wind speed increases, it is accompanied by low air pressure. So therefore the air pressure decreases. So now we have less air pressure in region 2 and we have more air pressure in region 2. So basically in region 1 we have low air pressure and in region 2 we have high air pressure. And again the same logic, air moves from region of higher pressure towards lower pressure. So basically air would move in this direction and this wind will pressurize the paper also to move in the same direction, and that is why the strip of paper tends to come up when we blow hard above it. So these are all experiments, and all of these are so handy that you can actually perform them yourself and you can enjoy the beauty of science. Now sometimes this concept of air pressure can be extremely dangerous. So you might be wondering that, okay, we learned about wind. So wind is actually a nice thing. When we go out and if there's a cool breeze blowing, we feel good. The trees move, we get to see a nice scenery. So there is nothing wrong with it. But sometimes this air pressure can turn out to be very dangerous. So here we will see that how the concept of air pressure can be so dangerous that it can even cause huge destruction. Because sometimes it sounds very surprising that how can winds cause so much of loss to the property? How can it cause the destruction of houses and roads and buildings? How can it cause that? So we will see that how the simple concept of air pressure can actually make the roof of a house fly away with the wind. So what happens during strong winds? What do we mean by strong winds? Now when we say strong winds, we basically mean winds which are blowing with a very, very high speed. Now when we say that winds with very high speed are blowing above the roofs, that means the speed of the wind is more, therefore the air pressure is going to be very less above the roof. So let's say this is a house. So just an example, right? So above the roof of the house, since the wind is moving at a very high speed, therefore the air pressure here is going to be less. But the air pressure inside the house is going to be more. So here the air pressure is more. So what happens here? The air pressure is more and here the air pressure is less. And we know that air tends to flow from the region of higher pressure towards lower pressure. So basically wind will end up blowing from bottom to top, and this would exert an upward force on the roof of the house, which results in the destruction of the house. So a lot of times the roof itself gets carried away with the wind. So therefore only those buildings or those houses survive which are like very strong and which have been built in such a way that they can resist or they can withstand the wind speed. So that's one thing. Whether destruction will happen or not, that also depends on the intensity of the wind, with what speed winds are blowing. So that is also another factor which decides how much destruction will happen. But here you see that just with the same concept of air pressure, we can understand that how the houses break under strong winds. So now the question is, from where do these wind currents generate? How it starts, how it originates. So we got to know that air moves from one region to another due to difference in pressure. But when you talk about the wind currents, so in the newspapers, you might have seen that a lot of times you get news like there is a cyclone which has taken place in Odisha, or there are strong wind currents in some regions of Karnataka. So these kind of news keep coming up. So how exactly these wind currents get generated? I mean, at the end of it, we want to know that why air needs to move from one region to another. So here we will again experiment with the balloons in order to understand the mechanism. Now, in order to understand this mechanism, we need to first talk about a very important property of air. So, and that property of air is what will be seen with this experiment. So here what we do, we take a test tube or a boiling tube, which is very commonly available in your laboratory. So you just take a slender tube, that's it. Take a balloon and tie the balloon over the neck of the tube. So the balloon is not inflated right now, it is just tied tightly using a thread or anything to the mouth of to the neck of this test tube. Now what we do, we put this entire tube inside a beaker which contains some cold water. So cold water in the sense maybe water at normal temperature. So what happens to the balloon? The balloon remains as it is. There is no change in the balloon. Now what we do is we take the same tube and put it in a beaker containing hot water. And what do we see? We see that the balloon gets inflated. Now, just think how temperature played a role in inflating the balloon. Now, when the balloon gets inflated, what is contained inside the balloon? Nothing but air. So basically, when it was put in the hot water, the test tube to some extent got heated up. So this heat was responsible for inflation of the balloon. So this heat caused the air inside the balloon to get expanded. So air expanded. Now when air expanded, it needed more space. It is something like in order to keep this balloon, you need very small space. But when you inflate it, it becomes big. You need more space. So inside, the air is actually expanding, so it needs more space. And balloon being elastic provides that flexibility to expand, and that's why it expands. But what do we learn from this experiment? So this expansion of air happened due to heating. Therefore, we can say that air expands when heated. So when we heat air, it expands, and this property is very, very important in order to understand the way wind currents get generated, because there we will see this property of air plays a very important role. Now we will perform another experiment using paper cups, and here also we will see, we will conclude with the same property of air. So here what we do, we take two paper cups, put them inverted, and please make sure that the paper cups are empty, because when you invert it anyways, if there is anything, it will come down. But please ensure that it is empty. So hang them inverted from a rod. So you take a rod, take two threads, and then hang the two paper cups in this way. Then what you do, you take a thread and tie it at the middle of the rod so that this rod itself hangs and it can stay in a balance. Now, since both the paper cups, they weigh the same, so they have the same weight, therefore when you actually hang this entire rod and this entire setup, so what happens is, after some time, it is in a stable position where both the paper cups are at the same level, right? So this is pretty simple and you can do it on your own. Now, what you can do is, you place a burning candle below a paper cup. So just below one paper cup. So let's call this as paper cup 1 and let's call this as paper cup 2. So below paper cup 1, we have placed a candle. Now due to the flame of this candle, what would happen? So it will kind of heat up the air which is present here in this surroundings. The air will get heated up. And what have we learned? That air expands on heating. So what do you think will happen in this case? Now as we start heating up paper cup 1, after some time what we observe is gradually paper cup 1 is moving up, and therefore the entire balance of the two paper cups gets destroyed. So the paper cup 1 is going up and the paper cup 2 is coming down. However, there is no external force which is being applied for this change to happen. So the only thing that we provided was this heat. And when this heat was provided, the air in this area, the air got expanded. Now when the air expanded, it needed more space. So it created more space for itself and it pushed the paper cup up. And that's why the paper cup 1 moved up and the entire balance got disturbed. Because when this moves up, obviously the other one has to come down. It is like the seesaw which you would have seen kids playing in the garden. So if this comes down, this has to go up. If this comes down, this has to go up. So that's how it is. So in this case, since it goes up, so obviously paper cup 2 comes down and the entire balance gets disturbed. So here also we see that with this experiment also, we understand that when we heat up air, air gets expanded. So the logic behind this is pretty simple. So So let's try to understand this concept of expansion. So let us say we have this much of space, and within this much of space you have these many particles. So that is one scenario where you see that a specific number of particles are localized within a region. Now, if this entire region starts expanding, so suddenly instead of this much space, now they have this much space, and the same number of particles are like scattered. So they are like present away from each other. So what happened? Now, as soon as it expanded, it needed more space. So it occupied more space. So that was one thing. The second thing is that when it occupies more space, so basically the particles get spread over a larger area. So overall, the weight of this particle, this entire thing as such, reduces when compared to this. So it is like something which is light, hollow. Why is it hollow? Because there is a lot of empty space in between. So that is going to be lighter when compared to something which is very compact and dense. So the same thing happens here. And the same thing happens with air as well. So when we heat up air, it expands. And when air expands, it becomes lighter. And when it becomes lighter, it tends to rise up. And that's what happened here. So here the air which is present here, this air was heated up, it expanded, it became lighter, and that's why it went up. So as it rose up, it pushed cup 1 also in the upward direction, and as a result the entire balance got disturbed. So this is another experiment which tells us very beautifully how air expands when heated. And this same thing can be observed in a lot of things. For example, when you look at the candle flame, where does the flame go? So the flame tends to move up. When you look at the incense sticks, which we often burn while doing puja, so the smoke tends to go up. When you burn a piece of paper, the smoke, where does it go? It tends to go up. So why is it always that smoke always tends to go up? That's because air expands on heating. So whenever you burning the paper, so the air above it starts expanding when heated, and therefore the air becomes lighter and the warm air rises up, and the smoke which we see is nothing but a warm